Hello, YouTubers. So we meet again, and today we are discussing the subject of electric circuits. Right, so if you haven't hit that subscribe button, you can do so right now. And if you need to have questions answered, you can just email me at my email address is mlungisi.m.nkosi@gmail.com. Otherwise, just put a comment so that we can try and address all your concerns. Right, as you are preparing for the exams, I'm sure electric circuits is one of those sections that you are thinking, but how do I figure this out? Now, we're going to do this so much, we're going to make it in such an easy way that, I mean, even your 5-year-old brother or sister or cousin will be able to follow. So just stay with me as we go through circuits. Right, let's begin. So essentially, when we talk about electric circuits, I'm sure many of you have already started with it, and you know quite a few components on it, right? So first of all, we've got what we call a cell, right? So a cell essentially just provides us with electrical pressure, okay? That's voltage, right? Now, first of all, I just want to explain this part so that you understand what exactly does this guy do, right? So we usually talk about potential difference. I want you to imagine you've got, a pool of water, okay? So there's our water there. And you want water to start flowing, right? Now, if you've got two sides that are actually just flat, okay? So if let's say the ground is flat, what happens to water? Well, the water simply will not flow, okay? And why is that? Well, simply because in this case, the potential energy on this side is simply equal to the potential energy on the other side. So let's say EP1 is equals to EP2. So the potential energy on both sides is basically the same, right? So we simply say in that case, there is no potential difference. So when there's no potential difference, it simply means that water will not be able to flow, right? So, but if I wanted a river to flow, right? A river will be able to flow in a situation where there is a difference in the potential. Okay, now I want you to look at this, right? So if I have a situation like that, so water will be able to flow easily in that case, isn't it? So why is that? Because the potential energy on the one side is not the same as the potential energy on the other side, okay? So essentially what we say is that there is a potential difference. Are you with me now? So it means when there's a potential difference, in this case, the river will be able to flow. Current, when we talk about water flowing, we talk about a river current, isn't it? Right? So what is that? It's the flow of water, okay? So this is what Ohm's law said. Now I want you to please listen to me carefully. He said, well, the current across a conductor, right, is directly proportional to the potential difference. Now, I want you to note. So the current across a conductor. So in this case, what is current? Current is simply the flow of charge. Simple as that, right? So current is the flow of charge. So when you've got electrons that are flowing, right, we call that current. It's the rate of flow of charge. So Ohm's law simply said the current across a conductor is directly proportional to the potential difference. What does that mean? It means the greater the potential difference, and I'm going to actually show you in terms of this, right? You agree with me that the steeper the surface is, the more current will be able to flow, the more water will be able to flow. So the steeper the surface, right, it makes water flow faster. So it means the greater the potential difference between the two areas, right, the greater the current. And that's exactly what Ohm's law is simply saying. It's simply saying the greater the potential difference. Now we're going to talk about electrical pressure this time. Okay, right. So he says the greater the potential difference, the greater the current will be, the more electrons will be able to flow. Okay, so meaning, now where do we get the potential difference? We get the potential difference from the battery. Now battery is made out of chemicals inside. We've got different types of batteries, right? But we're not going to really discuss that today. So what I want you to note is that when you've got a battery supplies you with electrical potential, meaning there's a side. Now we usually take the longer side of the battery as the positive side, meaning there's greater potential on this side and there's lesser potential on that side. Now this comes from conventional current. I won't talk too much about that today, right? So in this case, the greater the potential difference here, what does it do? It now pushes electrons to be able to flow. So once I connect this, all right, onto the other side, what begins to happen? Electrons now begin to flow. And that is why, and that's the reason why, if I put another battery there, so what am I doing? I am increasing the potential. I'm making it more steeper, right? So what happens? The more there's potential difference, in this case, the greater the amount of current that will be flowing. And that's simply what Ohm's law is simply saying. So in actual fact now, what we are simply going to have is that I, now we put an equal sign, we say I is equals to V over R. Now what I want to do is, I don't want to really spend a lot of time talking about where this comes from, but what I in turn want to do is I just want you to understand this from a perspective of how to apply the issue of circuits, right? Okay, so we say current directly proportional to the potential difference, all right, and obviously in this case it's inversely proportional to the resistance, right? So we'll talk about resistivity a little bit later, resistance of a resistor. So now I want you to please note, so by definition, Ohm's law simply says the current across a conductor, right, is directly proportional to the potential difference. So current is directly proportional to the potential difference, provided that temperature remains constant. So when we're talking about Ohm's law, we are always going to be looking at a constant temperature, all right? So meaning ohmic conductors are conductors that do not change temperature upon use, okay? So I want you to always remember that. So when we're talking about ohmic conductors, they actually maintain the same temperature. So that would tell you, in actual fact, there isn't such a thing as an ohmic conductor. We try to model it, but realistically speaking, there is no such a thing as an ohmic conductor. However, this does help us to work with electricity, right? So now we're going to be using the same formula. I is equals to V over R. And please remember, so I, that's current, right? And what is current? So current, we said that's the rate of flow. That's the flow of electrons. So those are electrons that are moving on about, or charge that is moving. And we measure that in amperes, right? And then voltage, what is that? That's electrical potential. So that's the energy difference between 2 points, isn't it? Okay, so that's electrical energy difference. So we call that voltage, right? And that's why at times they'll tell you about potential difference. And when we measure how we measure voltage, it's measured in volts, right? And then we've got this guy called resistance. Okay, we're going to talk about resistors in just a few. And resistance in this case is measured in ohms. Okay, so those are measured in ohms. So essentially, not wanting to talk much about how all of these components, right? I want you to please remember. So this is the application of Ohm's law. Some of you might even remember, there's this triangle that we often use when it comes to Ohm's law. So they say VIR, okay? So meaning that if I'm looking for voltage, right, it's going to be current times resistance. If I'm looking for current, it's voltage over resistance. And if I'm looking for resistance, it's always going to be voltage divided by current. Okay, so just I suppose it's a nifty way of just remembering your application of circuits. Okay, right. Now, so there are just a few things that I want us to get out of the way. All right, so how do we measure voltage? Okay, so we have what we call a voltmeter. Okay, so here's a measuring device called a voltmeter. Now, ideally, when we are dealing with the voltmeter, now please, I want you to listen to this carefully, right? So an ideal voltmeter has got infinite resistance. I'll tell you why that is important. Okay, infinite resistance. Okay, so if we say that an ideal resistor has got infinite resistance, meaning that any time that you've got a voltmeter, it will never allow current to flow through it. So therefore it will have zero current. So there's no current that flows through it. As I said, that is an ideal voltmeter. Okay, so a real voltmeter, one that we use in real life, of course it does allow just a little bit of current to flow through in order to make that needle to move, right? So or in the case of an electronic one, just to set the the screen on. Okay, right. And then you've got what we call an ammeter. Now that's very important. So anytime you've got a voltmeter, a voltmeter will never allow a current, it will never allow electrons, or ideally it shouldn't allow electrons to flow through it, right? And then secondly, we've got an ammeter. Now what does an ammeter do? Well, it measures the current that is flowing through it. So now for an ideal ammeter, note it has zero resistance. Okay, so this will have zero resistance. Okay, so if it has zero resistance, it will allow all the current, all right, at least it will allow all the current that it can to flow through it. So it allows maximum current. Okay, right. So maximum current. So I want you to imagine in the case of a voltmeter, I don't know if any of you have ever seen a pump that we use, for pumping tires at the garage, right? So what happens is that when there's air that's flowing through it, it doesn't give you a reading. But the moment you have got air, once you want a reading, what it does is that the moment it disallows air from passing through, then that's when you find that you get a reading. So what does it do? It closes the one side, closes the other side, and gives you the difference between the 2 points, right? So that's exactly how this guy works, right? So voltmeter will not allow current to flow through. So what it does is that it will measure the potential on the other side and the potential on the other side and give you the difference between the two. Okay, right. Now, insofar as the application is concerned, right, I want you to remember this, and what I want us to do in the next few minutes, I'm just going to focus on resistors that are connected in series. Okay, right. Now let's go on ahead. Right, now let's talk about resistors in series in just a little bit. Right, so when you've got a circuit, we said first of all we've connected this to a battery. Okay, so remember, once you've got more than one cell, so when it's a single one like that, we call it a cell. But once you connect them in series, we call it a battery. So you can look at it as though a battery is a plural for cells. Okay, for cell. Okay, so in this case, here it is. We've got greater potential. We use conventional current. We say this is greater potential. So what happens? electrons are going to flow in here. Right, I want you to note. So there's current that flows through there, and the current goes through resistor R1, right? And remember, we say it's a resistor only when there's current flowing. There's nothing to resist when there's no current flowing, right? So in this case, we've got a current flowing through resistor R1, and then the same current flows through resistor R2, right? So you can look at it in that way. So what we're simply saying is therefore that these resistors are said to be in series. Why? Because the same current passes through them, right? Now what I want to do with you is I want us to just clarify a few rules for resistors that are said to be in series. So first of all, what happens with resistors in series? Well, as I said, we say it's the same current that flows through them. So same current, so they experience the same current. Secondly, what happens? They are potential dividers. Now, please, I want you to listen carefully. So suppose a battery gives me a certain amount of voltage, all right? Electric potential. So there it is. I've got a battery that gives me potential, right? So the total energy or the total voltage that the battery provides will be the total energy that is used across my circuit. Okay? So in this case, if I've got a total of, let's say, whatever the case is, let's say 12 volts, right? So if I'm given 12 volts there, it means that the potential across this resistor plus the potential across this resistor should give me 12 volts. So what do? They share the voltage, okay? So they are potential dividers, or you can say they share the voltage. All right? So we say resistors in series, they share the voltage or they divide the voltage. And by the way, how do they divide it? We say they divide it proportionally, okay? Right, what does that mean? It means the bigger the resistor, just keep this in mind. I know for now you might be thinking, but I'm not too sure what you're saying. Just keep in mind, it will all make sense once we start, okay? Right, so we say they share the voltage proportionally, okay? And then what do we know? We say, well, the total resistance of the circuit. So I can take this circuit and make it into a simpler form, right? Wherein I've got only one resistor, all right? Let's call that one resistor R series, okay? If you don't mind, I'm going to call that resistor R series, right? But what is R series? So R series is simply the sum of R1 plus R2 depending on how many resistors that you have in series. So essentially what you'll do is that you'll add all your resistors together. Okay, right, great stuff. And then ultimately, and now we know that to find the external voltage, let me just call it V external. All right, so what is V external? It's the voltage that is actually supplied by your battery. Okay, I'm calling it V external now because later on I'm going to introduce something else, okay, that is the internal voltage, right? So just for me to be consistent, I'm just going to leave it as V external. Okay, so just remember, V external is sort of the total voltage that is supplied by your battery. Okay, right. Okay, so that's subjective for now because we don't have V internal. So V external will be equals to the voltage across resistor 1, okay, so we'll say VR1, plus the voltage across resistor 2, right, and depending on how many resistors you have, it will be until VRN. So meaning, if I've got 12 volts there, the voltage across this one plus the voltage across that one must give me 12 volts, okay? So I'm not sure why I keep mentioning 12, but maybe you should consider playing that on the lottery, né? Okay, so so V external, so the total voltage will be the sum of all the voltages across each single resistor. All right. Now here's one thing I want to also mention. Remember we said that the current flowing through this resistor here, right? Let's say that's the total current. Okay, it's the same current that would have flowed from the battery, flows through resistor R1. It will flow through resistor R2. Can you see? So what do we know about resistors in current in series? We said the same current flows across them, right? So as a result, now we know, okay, the same current flows across them, so it must be that they are in series. And by the way, now that I've made them into one resistor over there, please remember that even if I've made them into one resistor, the same current that was passing through there still passes across this one resistor here. The only difference now is that when I talk about this resistor here, okay, the voltage across this resistor is no longer just, let's say, the voltage across R1. So let's say if we measured across, let's call that VR1 and let's call that VR2, right? VR2. So the voltage VR1 and VR2 are the voltages between, so VR1 is just the voltage across resistor R1. Can you see that? Right. And the voltage VR2 is only the voltage across resistor R2. Now, let me tell you where the challenge is with most people when it comes to circuits. The rule in circuits is as follows. All right. Every time that you use Ohm's law, I is equals to V over R. All right. I want you to please remember this rule. You always use voltage, a particular voltage, with its corresponding resistor. Are you with me now? So you always use voltage with its corresponding resistance. Okay? So, for instance, if I were to ask you the voltage V, right? Which resistor does it supply? It supplies all your resistors in the circuit. Can you see that? So it means when I use resistor V, I can't just, voltage V rather, I can't use voltage V with just resistor R1. Okay? I can't use V with resistor R2. It means when I use that voltage there, V, I need to use all my resistors because the battery, remember, does not choose. It supplies all of our resistors in the circuit. Okay? Right. And then if I use VR2, for instance, which voltage or which resistance rather corresponds to this resistance here? Okay, to this voltage here. Which resistor does it correspond to? It corresponds to resistor R2. Can you see that? So therefore, when I use VR2, well, it goes hand in glove with what? Resistor R2. Okay, right. So what I want us to do in the next few minutes, all right, we're going to be discussing very quickly, all right, how to apply Ohm's law in circuits or in circuits whereby resistors are in series. All right, just keep this in mind and then you'll see how that applies. Is that good? All right, let's go. All right, so let's take a simple circuit like the one that we have there, right? So what I want us to do, first of all, ladies and gents, what I want us to do is we're going to look at this question, but there are certain assumptions that we're going to make beforehand. All right, so for now, I'm only looking at batteries that do not have an internal resistance. We'll come to that a little later on. Okay, but what I want us to do for now is I want us to be very fluid, okay, to be very solid in how we solve for circuit questions, right? So let's take this question and let's move with it so that you know how to apply this. So first of all, what I want you to do, I want you to please note. So we know there's the positive and the negative side, right? Okay, so what happens? Let's analyze the circuit first. right? So we've got current that is moving from the positive side of the battery. That's remember we said we take conventional current, right? Okay, so from the positive side of the battery, is there current that's going to flow through the voltmeter? Absolutely not. You remember we said that, right? We said in an ideal voltmeter, there is no current that flows. So in this case, we've got a current that flows through here. And then what happens? We know that the current will flow through the 8 ohm resistor. The total current will flow through the 8 ohm resistor. Agree? Right? And then what happens? We know that the current now is the current that's going to flow through this voltmeter here? Absolutely not. So in this case, the total current flows across the 8 and the same current flows across the 4 ohm resistor. Remember, why did we say no current flows across a voltmeter? We said this guy has got infinite resistance. Okay, so as a result, we know that current will simply not be able to flow. All right, so now what we're simply saying is how do we attack this question? So we know current flows through there, the same current flows through there. So what can I say about these two resistors? Because the same current flows across them, then they are in series, right? So it means these two resistors are in series, right? So as a result, now I want you to please also note which current will pass through this ammeter here. It should still be the total current. Can you see that? I mean, it has no other alternative path to go through. It can only move through these resistors, 8 ohm, 4 ohm, and thereafter go back to the lesser potential side of our battery. All right. Now, they are telling us the reading on V is 15 volts. Now, please, I want you to note, we'll always start where we've got the most information. Okay. So they tell us that the reading on V, now where is V? V is this guy over here. So they tell us that the reading on this guy is 15 volts. Okay, so now we're going to check. All right, so what do we do with that voltmeter there? Right, so we're going to say, all right, so which resistor does this battery, now remember, what is the voltmeter reading across? It's reading across our battery, right? And which resistor is the battery supplying? It's supplying all of our resistors combined, isn't it? So in this case, we're going to simply say, all right, so our voltmeter is supplying all of our resistors in the circuit. Now they've given us this 15 volts. Corresponding resistance is all our resistors. So they said, first of all, calculate the reading on A, right? So we want the current. We're given that voltage. Corresponding resistance is the total resistance. So I'm going to start there. Say, right, first of all, let's find out what is our resistors in series. So RS is equals to R1 plus R2. If you had other resistors, you'd add all of them up. So this is going to be 8 plus 4, which gives you 12 ohms. Okay, so now that I've got my total resistance, I am going to use Ohm's law, right? And say, well, I know I is equals to V over R, right? But please remember, I'm looking for current. So which current am I looking for? For the total current. So what have I actually done? I've now reduced this circuit into one resistor, right? I've actually made this circuit to have just one resistor. And what's the value of that resistor? It's 12 ohms, right? So now, which current passes across the 12 ohm resistor? It's still the total current. Can you see? So now I'm going to say I is equals to V over R. My voltage that is given, it's my total voltage, which is 15, okay? Divided by my total resistance in this case, which is 12. And what does that give us? So that's going to be 15 over 12, and that gives us 1.25. So that gives us 1.25 amperes. So the current reading on A is 1.25 amperes. Now, let's remember. So which current is passing across the 8 ohm resistor? It should be the total current, right? which current is also passing through the 4 ohm resistor? It should still be the total current. Okay, so in this case, now that we found the total current, we know the current passing across 8 ohm. We also know the current that passes across the 4 ohm resistor. Okay, but look at this. We also know the current that passes across the 12 ohm resistor, which is the sum of these two. Okay, right. Now let's go for the second question. Now they are asking us, calculate the voltage V1. Okay, right. So let's find out the voltage, or rather the potential difference across on V1, or the reading on V1. So now the question is, what is V1 reading across? Right? Remember we said voltage with its corresponding resistance. So our voltage V1, can you see there? Right? What is it reading across? It's only the 4 ohm resistor. Can you see that? So when you use V1, there's no way that you can use V1 with any other resistor. You can't use it with the 8. You can't use it with the 12. It's only the voltage across the 4 ohm resistor. So now I'm going to say, all right, so V1 is equals to I, that's I total, multiplied by the resistance of it, right? So in this case, what is the current that passes across that 4 ohm resistor? That's the total current. You're right. That's 1.25 multiplied by 4, right? So in this case, I want you to please note. So let's do that. So we get 5 volts. Okay. So it means that the reading on V1 is 5 volts. We get a reading of 5 volts. Now, please, ladies and gents, let me just do this so that you just keep this in mind, right? So now that I know the voltage across the 4 ohm resistor, right, is it possible for me to find out what is the voltage across the 8 ohm resistor? Okay, well, there are two ways of doing that. I want you to please keep in mind, what did we say? We said in series, right? If our resistors are in series, it means that they divide the voltage, right? The battery is supplying us with 15 volts, right? But this guy is only using 5 volts. Where's the rest of that voltage? Remember, we said the voltage that is supplied must be the voltage that is used. Okay, so this guy is supplying us with 15 volts of voltage, right? The battery is supplying us with 15 volts, but now we only use 5 volts across the 4 ohm resistor. So where's the rest of it? Of course, it's over here on the 8 ohm resistor. Now, there are two ways in which you could find out what is the voltage across the 8 ohm resistor. I know we didn't ask that there, but if I wanted to determine the voltage across the 8 ohm resistor, so number one, I could say, well, the voltage across the 8 ohm, okay, I'm just going to write that there. It's going to be the current. Now, which current is passing across 8 ohm? It's going to be the total current multiplied by the resistance, right? So which resistance? The 8 ohm resistor. So you could say this is 1.25 multiplied by 8, okay? And this would give you guessed it, 10 volts, right? Because at the end of the day, I know this plus that should give me that, okay? So we get a value of 10 volts. Or you could have actually calculated it this way. You could have said, well, but I know that V total or V external is equals to V1 plus V2. Okay, so my total was 15. Okay, and I know that V1, which was the one across the 4 ohm resistor, was 5. Okay, and I'm looking, let's call that V2, or we can maintain that as V8 ohm, right? So in this case, what is the voltage across the 8 ohm resistor? And we can just simply take the difference between the two. If you take that to the other side, 15 minus 5, that will give us 10. So the voltage across our 8 ohm resistor is still going to be 10 volts. Okay, so either way, you could have gotten it this way or that way, but ultimately we end up at the same place. All right, so in this case, we applied our principle of circuits. We realized when we've got resistors in series, current that passes through there current that passes there, right, should be the same. And in this case, look at that. We said they divide potential, they divide voltage, right? And they divide voltage proportionally. We said, what does that mean? It means the bigger the resistor, the bigger the voltage across it. Look at this. The 8 ohm resistor, right, took the lion's share of that 15 volts that was provided. It took 10 volts, right? And whereas if you look at that, the 4 ohm resistor only took 5 volts. So yes, they shared the 15 volts, but they did not share it equally, but they shared it proportionally. It means the bigger voltage, the bigger resistor took the bigger voltage. All right. So in this case, that is how we would solve that. I hope that makes sense. Let's take another question. All right. So that we can see how to apply resistors in series some more. Right, let's take this circuit and see how to maneuver our way through it. So the first thing, remember that we said you must always analyze your circuit first, right? So remember, the longer side always represents your positive side, and the shorter side is always your negative side. So in this case, I've got two batteries, two cells, okay, that are in series with each other. So now let's have a look at it. All right, so total current flows out of here, passes through the 10 ohm resistor, right? And then total current continues, and then we get to this point here. Is there any current that flows through voltmeter V1? Absolutely not. So you know, in this case, this is not going to be, there's no current that will flow through that. Why? It's got infinite resistance, right? So total current flows through 10 ohm. So therefore, the total current will also flow through the 6 ohm resistor. Can you see? Right? No other choice, but it has to flow through the 4 ohm resistor as well. And that total current is still also going to flow through that ammeter A there. And then obviously until it gets back into the battery, right? So in this case, what we simply are saying is that, all right, so same current passes across the 10, passes across the 6, passes across the 4. What does that say? If the same current passes across all our resistors, so we know those resistors must be in series, okay? So those resistors are in series, right? So now let's see, how do we maneuver across the circuit? Now, what are we given? We said we're always going to start with what we are given, right? So the reading on V1 is 4.8 volts. Now let's check. Where is our V1? Remember, that's V there, and V1 is the reading over there, okay, so that we don't make an error. So what is V1 measuring? Okay, it's measuring the potential difference, the voltage across only one resistor. And which resistor is that? It's the 6 ohm resistor. Can you see that? So we're simply saying, remember, you use voltage with its corresponding resistance. You see, once you get that principle, ladies and gents, I'm telling you, half our work is done. Okay, so in this case, we're going to say, all right, so we now know the voltage across that resistor there, 4.8. So that's where we're going to start. Now they said to us, let's calculate the reading on A, meaning the total current there, right? So remember, I know that the total current passes across there, but the total current passes also across the 6 ohm resistor. So if I can find the current going across here, right, because I've got the most information there, so I therefore would know the current passing through the ammeter A, right? So in this case, I'm going to say, all right, so once again, it's going to be I, so that's going to be my number 1. So I is equals to V, but which V? V1, voltage with its corresponding resistance, over R, right? So we're going to have that resistor there, right? So that's going to be V1 is 4.8 divided by corresponding resistance is 6. And what does that give us? It gives us 0.8 amperes. So it means 0.8 amperes of current pass across all our resistors there. So the reading on A should be 0.8 amperes. All right. Now let's go through the next one. So then for the next one, they're looking for the reading on V. Okay. So now look at this. What is V? V is our total voltage. So it means we're looking for the reading across our battery. And please remember, which resistor does the battery supply? It supplies all our resistors in the circuit, right? So if we are taking that notion of resistor voltage rather with its corresponding resistance, so in this case the voltage V supplies all our resistors, so all our resistors combined, so that's our series combination, right? So I'm going to say, look, let's just reduce that circuit into one. Okay, so let's just redraw this there, and then we're just simply going to have that resistor become just one there. Okay, so we're combining all of them, right? So that we know the voltage that we have there supplies that resistor there. So it's going to be 10 plus 6 plus 4, that gives us 20 ohms, right? So we know that R external, okay, right? So I'm using that word so that you'll just remember it. So we call these our external resistors, right? So I'm kind of preparing you for what is coming, right? So R external, or you can simply call it R series in this case, because they were all in series, right? So R external, we know they are in series, so that's going to be R1 plus R2 plus R3. We've got 3 resistors, isn't it? So this is going to be 10 plus 6 plus 4, and that gives us 20 ohms. Okay, right. So now that we've got our resistors, we want to now find out, okay, so what we wanted to find out was that reading on V there, right? So remember, V supplies all our resistors. Now I want you to please note, what did we say about resistors in series? We said current is the same, right? So meaning the same current that passes there, I total, is the same current that passes across 6 ohm, that's I total. It's the same current that passes across there, right? That's I total. Now I want you to please note, even when I combine all of them and make them into one resistor, which current passes across there? It is still I total, ladies and gents. Can you see? Right? Because in this case, there's no other place wherein right, I total can actually branch off to. So the total current passes across that resistor there, right? So now I want my total voltage. I know what my total resistance is, right? We said voltage with its corresponding resistance. So now I'm going to say, all right, so I'm looking for V external, okay? Or you can call it V total. I'm just very wary of using that term for now. Okay, so V external is going to be I total. V is equals to I times R, right? So V is equals to I total multiplied by R external, okay? Voltage with its corresponding resistance. Can you see that? Right, so now I want to find out, okay, what is my total current? My total current, we said that's 0.8. Remember, we said it's the one passing through there. Multiplied by what is the corresponding resistance? You're right, this is 20, right? So in this case, what do we get? So we're saying 0.8 multiplied by 20, so 0.8 times 20. Okay, so that will give us 16 volts. Okay, so it means that in total, our battery is actually supplying us with 16 volts of energy per unit charge, right? So in this case, so that's V external. That's V, or our value of V is 16 volts. All right. Now, please, once again, I want us to check, right? Is that what we are going to get? So this, we are done answering the question. Is that what we'll get? Remember, we said voltage that's supplied will be the total voltage that is used across our circuit, right? So let's check. If we say that, remember we said this is 0.8 amperes of current are going to pass there, 0.8 there. So we know the voltage here is 4.8, right? So let's check. So we're just doing this so that we can fact check, right? So we're saying what is the voltage across our 10 ohm resistor? It's going to be I total times R. So this is 0.8 times 10, which is 8 volts, right? So that will give us 8 volts. And then note again, so this is the voltage across our 10 ohm resistor, right? And then what if I'm looking for, now we're looking for the voltage across the 4 ohm rather, because we already have this one as 4.8. So again, it's going to be I total, right, times the resistor. You can call it R3, whatever you want to call it. So this is 0.8 multiplied by 4, okay, and that will give us, okay, so multiplied by 4, that will give us 3.2, right? So let's check. So if I take, okay, so let's check if all of those voltages combined actually give us that 16 there. So I've got the voltage across the 10 ohm resistor. We said that's 8, okay, plus the voltage across the 6 ohm plus 4.8 plus the voltage across the, okay, I forgot to put the SI units there, right, plus 3.2, okay, so that gives us 16. Can you see that? So in this case, it tells us that the total voltage that is used, okay, is supplied rather by the battery, is equal to the voltage that is used, and that's 16 volts. Okay, right. Ladies and gents, I hope you are getting the gist of it. Okay, so that is in turn how we actually just do questions on circuits, right? I just want us to take the last one, and then we are calling it a day when it comes to resistors in series. Okay, right. Okay, so let's take this very last one. Okay, and I'm going to just leave you with a bit of an activity for you to do for me, and then just throw it on the comments. I'll let you know just at the end. Right, so they say the reading on V, okay, so we've got a circuit there. They say the reading on V is 36 volts. So there's V over there. All right, and then and that of A is 0.5 amperes. So they've given us the voltage across our battery there, right? And then they've given us the current that passes through that ammeter there. So once again, remember we said we're going to analyze, right? So total current passes across, our current passes through the ammeter there. So because we know the current passing there, they said it's 0.5. So in actual fact, we know now the total current is 0.5. Okay, what happens? We get to this point here, we know there's no current that's going to pass through a voltmeter, right? So actually, all the current will pass through the 10 ohm, as well as the 20 ohm, as well as that resistor, that unknown resistor there, Rx, okay? Right, and eventually we get back to the battery. Right, so now we know the voltage there. So we've got the total voltage. We also know the total current, isn't it? So now we're going to simply say, all right, how do we now find the voltage reading on V1? Okay, so I'm sure you've got it by now, right? What is V1 measuring across? V1 is measuring across two resistors. Can you see that? Okay, it's measuring across the 20 ohm and the 10 ohm resistor. Can you see that? So we said voltage with its corresponding resistance, and we know those two are in series, so we're just going to add them up. So to answer the first question, I'm just going to say, okay, so R series, okay, so let's say R series, that's going to be R1 plus R2, okay, so that's going to be 10 plus 20 That gives us 30 ohms. All right. So that's that series combination there, right? But we're looking for V1. So we know we're going to say, but we know the current that passes through there, isn't it? Right? The same current passing there will pass through both of those resistors combined, isn't it? So now we're going to say it means V1 will be I total, okay, multiplied by our resistors in series there. So this is going to be 0.5 multiplied by RS, okay? RS, we said it's 30, and I get a value of 15 volts, okay? So I get a value of 15 volts. So it means the voltage across those two resistors is now 15 volts, okay? Right, and now for the second one, ladies and gents, we're looking for that value of Rx. I'm sure by now you know what to do, okay? Right, so how are we going to get the value of Rx? Okay, right, now please, I want us to stay together. Right, so what do I know about Rx? What do I know about this resistor here? What's happening? I know the current that's passing through this resistor here, isn't it? Okay, and what else do I know about that resistor? Okay, so I'm going to show you two ways of actually calculating for that. Okay, I'm sure you'll have actually you would have figured by now. In fact, if you can, please just pause the video and try to calculate Rx for yourself, right, and see if your answer compares to mine. You can pause it now and then just look at the solution later. Right, now look at this. I'm simply going to say, when I look at those resistors, okay, I'm given the 36 ohm, the voltage, the total voltage, which is 36 volts, isn't it? So I know that's my total voltage, but which resistor does this correspond with? It corresponds with all my resistors that are in the circuit. So I can say, but I know V external, right? So if I'm looking for, if I've got V external, can I not find R external? Can I not find all my resistors combined? Right? So R will be V over I, isn't it? I know my V external, right? All my resistors, right? All my resistors combined go hand in hand with that total voltage there. So that's divided by I total. So therefore V external, this is 36 volts divided by what is my I total? We know that's going to be 0.5, okay? All right, so you get a value of 72 ohms there. Now, what is this value here? Remember, this is the resistance of all your resistors in the circuit. So it means all your resistors combined give you a total of 72. I'm sure you've got that figured out by now, that actually this plus that gives us R external, isn't it? So therefore, it means that R external will simply be, now I want you to note, because they're in series, R1 plus R2 plus R3, and so we add them all up. So this is going to give us 10 plus 20 plus Rx, right? So we want the value of Rx, but we know that our total is already 72, okay? So you can just do your mathematical gymnastics there, and your value for Rx, right? You'll just simply say 72, okay? Minus 10 minus 20, or minus 30. So that should give you 42 ohms. Okay, so that's the value that I get there. Okay, so if you wanted to just check another way of calculating the same thing, look at this. I can actually just simply say, now look at this, I can just simply find out what is the voltage there. Now I'm already given the fact that this is 36 volts, isn't it? So I was given that to be a total of 36, and I know that the total voltage supplied must be the total that is used across my circuit. I already know that I've used 15 across those two, right? So where's the balance of it? Of course, it should be across Rx. So I'll say 36 minus 15, right? Okay, so in this case, so I'll say the voltage across Rx will be 36 minus 15, right? And so what will that give us? It will give us 21 volts. Okay, now that I've got the voltage there, but I also know what the current is, isn't it? So I can say, well, it means that Rx, now note, it's going to be VRX over I total. I know the current that's passing there. R is V over I, isn't it? So in this case, I'm going to have VRX, that's 21, divided by the total current is 0.5. And I want you to note, you still get the same value, which is that 42 ohms there. So that's another way of calculating Rx. All right. So what I would like for you to do for me, just as an exercise, all right, just to check if you are listening. All right, I want you to please calculate for me the voltage across only the 20 ohm resistor. All right, and put that as a comment. Okay, right. But otherwise, I hope that has been very fruitful. Okay, I hope you now have a better understanding of circuits. Otherwise, I'll see you guys next time. Thank you so much for watching, and please, we're going to be doing more circuits, by the way, next time. We're going to be looking at resistors in parallel, and then thereafter we're going to just combine all our resistors, right? But otherwise, it's been such a great time. Please don't forget to subscribe if you haven't, and please, you can ask any questions on the comment section, or you can just hit me up on my email. Otherwise, I'll see you next time. Thank you, ladies and gents. Sharp, sharp.